Okay, so part C, and this is where it gets a little bit complicated, is power of a power. Okay, when we're dealing with power of a power, it's really important to take your time because there's a lot happening, right? All at once. This is actually a little bit different. So in the last video, multiplying meant adding the exponents, dividing meant subtracting. Power of a power, you are going to multiply the exponents together. Okay, we'll see what this looks like in 1 second. This is the one area where I guess it's more true, right, to the operation of what it's doing. So always watch for brackets. I'm going to write that actually right down. Okay, keep your eyes peeled for any brackets. So let's try the first one. Again, I think just having an actual concrete example will help the most. So let's start off with a number as our base. So let's say we have 3 to the power 4, but then it's also to the power of 2. Okay, there's a few ways that we could tackle this. That squared means you're going to repeat that entire bracket twice. So we could write out 3 to the power 4 times 3 to the power 4. An easier way dealing with our exponents, so our base is 3. What I do is I circle around the exponents in whatever color I'm working with. So that is the 2 exponents you're going to multiply together. I can prove why that's true by using my laws I already know. But this is going to speed up the process a lot, especially again if your exponents are quite large. So let me start by solving it. So we have 4 times 2 as our operation. Okay, and we get our answer of 3 to the power of 8. Okay. Now, you're probably like, why is that true? We just did multiplying where we added. Let's try to prove it then with what we already know. So 3 to the power of 4 times 2. We know what this looks like. X times x is x squared. It would be 3 to the power of 4 times 3 to the power of 4. Let's use our regular old exponent laws. So we would take our base of 3, our exponent of 4, and right there you can probably see it working out quite nice. We set our exponent into place. Again, just referencing the last video. We add our exponents. And right away we get our answer, 3 to the power of 8. Okay, exact same process. Sometimes there's different ways that you can do it. But again, I'm just using this way because it's what we already know. Now, the main thing is there will always be a bracket and a power of a power. So what I would do is just, like with my personal notation, I always use brackets. Keep your eyes peeled for a bracket. When you see it, you're going to use power of a power, unless it's a negative value encompassed in brackets. Okay, let's try a couple more. So let's try a letter example. Let's say we have p to the power 6 times 3. So same thing, I'm going to underline my base, which I don't have multiple terms, but it's just going to be whatever is at the bottom. So p, and I believe it's called a superscript when it's up above the little smaller numbers. Those are our 2 exponents. When they're right beside each other, I circle them to indicate I'm going to multiply them together. Okay, it's just my little process. Learned it in 5th grade. It's just always stuck, to be honest with you. So my base is p. I'm going to take my 2 exponents, 6 multiplied by 3. And then that's basically it. I'm just applying the operation all the way through. 6 times 3 is 18. Can I evaluate? No, it's a letter result. Okay, that's as far as I can possibly go. Even 3 to the power of 8 is pretty big. We'll see one where it's a little bit smaller. Okay, so again, that's just simplified. Let's try another one. So what about if we have a coefficient? Like this. Okay, notice that 2 is there. So we're going to break it down a little bit further. I'm going to introduce the color of green for my coefficient. My base will be blue, and my exponent is going to be purple. Okay, I'm just going to write below, because I'm introducing something new, that my green actually represents my coefficient. Now, the important thing is that exponent of 2 applies to everything. So the 2 applies to the 2 as the coefficient. It's also going to be circled up with my 4. Basically, whatever you see in your term, 2m to the power of 4, just raise it to the power of 2. So my first step is dealing with my coefficient. That exponent applies to the 2. I set my base down as m. And then my last step is multiplying my 2 exponents. So 4 times 2. Once you have this set up, the rest is really just following through with the operations. So that's what you're going to do. You're going to do 2 to the power of 2, which is the reasonable number. 2 to the power of 2 is the same as 2 times 2, which is 4. Your base is always just the same. You don't really have to do much with it. You just need to make sure it's attached to your term. In this case, it's the letter m. And last but not least, you have your exponent, which is 4 times 2, 8. So we're not doing 4 plus 2 anymore. We're doing 4 times 2. Okay, let's look at a couple of other cases, just so we have this down pat. Let's do something really funky. So what if we had 2 to the power of 5 over 2 to the power of 3 squared? Okay. This one gets a little bit weird because you can realistically do this however you like. Right away, I got 2's. Those are my base. It's a larger number. I have exponents. This 2 applies to here. And it applies to the 3 down below. You could do this one of 2 ways. You could work within your bracket and then apply the power of 2, or you could apply the power of 2 and then solve within the bracket. It doesn't matter. By BEDMAS, it wants you to deal with the bracket first. Okay? So that's what I would do personally, just to follow the laws of operations. Is I would do 2 to the power of 5 and then subtracting by 3 for 2 to the power of 3. I would leave this value of 2 for later. Up to you though, it will work either way. So I'm going to keep my bracket. I know my base is 2, and I'm now going to write my subtraction of 5 minus 3. Okay. That 2 is just hanging out on the outside. I haven't quite done anything with it yet. Okay, so let's see what I get. I'm going to simplify this part. Okay, so I get 2, and I have 5 minus 3, which I already know how to deal with, is 2. And then I also know that 2 is outside. Wow, sorry, lots of 2's. Okay, I've simplified my expression. Now I'm going to apply my exponent laws. I'm going to do 2 times 2. We already probably know what this should look like, but let's write out all the steps just in case. So 2 times 2. And we'll get our final answer of 2 to the power of 4. Looking back at everything that we just did, if we first distribute the 2 to the 5 and the 3, we would have 2 to the power 10 and then 2 to the power 6. 10 minus 6 is 2 to the power 4. We would get the same answer, okay? Just keep that in mind. So this is simplified. Okay. And my last step is evaluating. So 2 to the power 4 is a friendly number. We can pop it into a calculator. It otherwise looks like this. 2's multiplied together 4 times. 2 times 2 times 2 times 2. 2 times 2 is 4, times 2 is 8, times 2 is 16. Okay, so again we have our evaluated answer. Okay, so the key difference, power of a power, yes, is quite tricky. It introduces new concepts like applying the exponent to the coefficient, but overall majorly follows the same kind of laws. So I would try all the practice questions in the module and try to get yourself as familiar as you possibly can.